All right, so the addition rule is fairly easy. A couple things we're going to talk about first. But are we ready? You do have a math Excel.
Only 2 slides.
Where do you see 2 slides?
I thought you said we only had 2 slides today. So it's a warm up.
Oh my God. Tell you what, the struggle is real. There we go for our 4th slide of the day. Mutually exclusive. You need to know what mutually exclusive means. It means there's no overlap. There's no intersection. They have nothing in common. Okay? So aces and kings have nothing in common. They're 2 separate types of cards. But if you're talking about hearts and kings, you can find a king of hearts. So if you can find something in both groups, that's not mutually exclusive. Okay? You cannot have an ace-king card. But you can have a king of hearts. All right? Easy enough. Mutually exclusive cannot occur at the same time. They have nothing in common. The intersection is 0. Okay? Moving on. So, determine if they're mutually exclusive. Rolling a 3 on a die or rolling a 4 on a die. Is there a die side called 3/4? No. So this is mutually exclusive. Randomly selecting a male student and randomly selecting a nursing major. Are there males that are nurses? Yes, so this is not mutually exclusive. You can have a male nurse. That's a thing. All right. Jack from a deck of cards and a red card. Are they mutually exclusive? No, because you can have a red jack, right? Jack of hearts and jack of diamonds. All right. So not mutually exclusive. Easy enough. Here we go. The addition rule. If you hear the word or, that means union. That means union. Okay? So sometimes the rule will show this, A union B. It's basically the probability of A plus the probability of B minus their intersection. So this is sometimes shown as the intersection. A and B is the intersection. If they're mutually exclusive, the intersection 0. So sometimes they don't even show that on the formula. I just memorize this formula. Just minus 0. So you don't have to think of too many things. Okay? So this can be more than one event, or more than 2 events, I'm sorry. It can be 3, 4, whatever. You're always subtracting out the intersections. Okay. So why do we have to subtract out the intersection? What's the deal there? Here we go. Magic. Read that slide. You ready? Is that good? Thank you, Sabrina. Here we go. Find the probabilities of mutually exclusive events. So we show the volumes of sales in dollars, blah, blah, blah. Use this sale pattern. Find the probability that the sale representative will sell between $75,000 and $125,000 basically next month. So we're looking at these 2 sets, yes? So what does this add up to? We have 8, 14, 21, 36. So 7 out of 36 is my first group, plus 9 out of 36 is the next group. What's the intersection? 0. Four ninths. All right. Does that make sense? They're mutually exclusive, yes? Okay. Find the probability that a donor selected has a random type O or type A. you have an OA blood type. No, they are mutually exclusive. So what's the probability of having O? 184 out of 409. And A is 164 out of 409. I think it's going to get cleaning. So that is 348 out of 409. Can I leave it as a fraction? Yes, you can. Okay, easy enough. Find the probability that the donor selected has a random type B or is Rh negative. So B is 45 out of 409. Rh negative is 65 out of 409. Are these mutually exclusive? No. Right? We have, what do we have in the intersection there? Okay, so you have 110 minus 8 is 102 out of 409. Does that make sense? Easy enough? Addition rule. Okay. There's a summary of probabilities for you. This is what we went over the last few days. Classical probability is just your basic rolling a die, what should happen. Empirical means you already did an experiment, you have data collected, and you're going off of that. Range of probabilities between 0 and 1, inclusive. Complementary events is 1 minus the probability of the event. Multiplication rules, what we did last week, it's the and. You multiply the two probabilities together. And addition rules, what we did today. You should have those kind of in your head. Okay, last slide, for those of you who are counting. Use the figure on the right to find the probability that a randomly selected draft pick is not a running back or wide receiver. So there's a whole bunch of numbers up here. Do we have to add them all up? Can I just take the running backs? How many are running backs? 23 plus 31. That gives me 54. So there were 253. Can I subtract the 54? They want you to do it by probabilities. Let's do it that way. So the probability of it being a running back or a wide receiver, they can't be the same, right? There's no overlap here, is 54 over 253. So probability of it not being that guy would be 1 minus that. So 199 out of 253. Easy enough? So think of the easier ways to do it. Complement's a nice, easy way to do it. Okay? We good? All right.